question is, your most recent works have addressed the pharmacokinetics of microplastics in aquatic organisms. What is your opinion? Are micro or nanoplastics accumulating or being excreted by organisms? And can we extrapolate the same is happening in humans?
Well, I think it's been clear for quite some time now that microplastics are ingested and that they can transfer from the gut to the circulatory system. They pass around the circulatory system. The extent of that depends a bit on the size and it depends on the creature. But it's been clear, I think we published on that back in 2008, using the mussel Mytilus edulis. We showed transfer of microplastics from the gut, and we showed that those plastics could be retained in tissues for several weeks afterwards, even if you kept moving the mussel to clean conditions. And then we repeated that work with nanoplastics more recently, around about 2018, with radio-labeled nanoparticles. And we showed, again, really readily transfer from the gut of nanoparticles of this time polystyrene to the circulatory system. And within 6 hours, those particles had passed to, you know, more or less all of the body organisms, body tissues of the mollusk. Interestingly, though, when you move the mollusk to clean conditions, what we saw is the excretion of those particles over time. There was still some trace, the plastic particles, around about 4 weeks later. So they haven't all left the body, but quite a lot of them have. So it seems pretty clear to me, just from the evidence in our lab, and of course, there's a lot of other researchers that have done similar studies too since then, that microplastics and nanoplastics are ingested, that they can pass from the gut to the circulatory system, that they can pass in, but they can also pass out. However, there is some evidence that particles are retained in some body tissues, and I think that will be a really interesting area for future research to think which tissues are they accumulating in, and do they cause harm in those particular tissues or organs. And to your question on human health, I mean, of course, we have much less evidence on humans because it wouldn't be ethical to do an experiment on a human with fluorescently labeled polystyrene pieces of plastic. So we don't really know for sure, but the animal models that we use, I don't see any reason why we wouldn't expect to see the same kind of responses in humans. There have been other studies working with a range of different creatures. Most of my work's been on mollusks or on invertebrate worms, but there's been work on higher organisms, and I see no reason that we shouldn't see that in humans. And indeed, there are some studies demonstrating the presence of at least chemicals associated with plastics from the circulatory system in the blood in humans, for example.
Yeah. And do you think from your studies, the ones that accumulated, the microplastics that were not excreted, do they have a particularity, some smaller size or different chemical composition? Do you have any idea which is the factor leading to the excretion or accumulation in tissues?
No, I think that's a really important question. What is it that leads to accumulation compared to excretion? And I think it's going to be a combination of the organism and the physiology and anatomy of the organism in connection with the size and shape of the particles. And I think it's not that, you know, there's one particular size that's going to be especially harmful across the spectra of organisms. I think it's going to be different sizes and shapes that might cause harm in different types of creature. Or indeed, putting it the other side of the coin, different types and shapes will potentially not cause harm in some creatures. I think it's going to be, the effects are going to be variable. But just to emphasize, I mean, I use the word harm there. There's none of what we've talked about so far really points to is uptake, ingestion, it points to transfer to the circulatory system, and it points to excretion, but also some accumulation. It's an important step to understanding harm, but in itself, it doesn't confirm harm to those creatures that I've just been talking about.
Yeah, of course, you're just talking about the movement of the particles, because we have to identify first where they move so that we can test what tissue, if the tissues are being harmed or not. So the next question is, you have been involved in Minderu Monaco Commission on plastics and human health. What were the most important recommendations in your opinion? Do you think governments will implement them? And what do you think is the major deterrent in the implementation?
Well, I think the clear message from a wide range of sources, the Minoru Monaco Commission report, and others, is, in its simplest terms, that our current production, use, and disposal of plastics is simply not sustainable. In my view, the root cause of that is that the business model that we're using dates back probably 70 years to the 1950s, when though we saw a transition in the types of applications for plastics. Up until that time, I'd be clear that to me, plastics are wonderful materials that have their place. They have a place, a role, potentially in reducing our footprint on the environment. They have a place in reducing suffering, in reducing food waste, a whole range of different things. They have a place in reducing carbon emissions and helping us fight against the challenge of climate change. But the business model we've got that stems back to mass production, which first really came online in the 1950s, is that suddenly we were able to have items that were so inexpensive to produce and to mass produce that we could have them for an instant and throw them away for our convenience. And 40% of all the plastics we make are items of packaging, single-use items, if you like, that have a very short life in service, very long persistence as waste. And I think it's that business model that's at the heart of the problem. If we went back to the 1950s, globally, we were making about 5 million tons of plastic. The 40% of that was perhaps packaging. It was wasteful. It wasn't a nice waste, but probably on a global scale, it was manageable. Today, we're somewhere between 300 and 400 million tons of plastic, 40% of it, again, single-use packaging items. The planet can't sustain that level of waste. And I think that's a key point to this, that the level of waste that we're producing is simply unmanageable. But that can't just be tackled by improving waste management. It needs to be a systemic change right along the supply chain, right from the design stage, if you like. I mean, a fundamental flaw in the business model that we have at the moment is that it's linear use of fossil oil and gas to highly persistent waste through short-lived applications. But there's been really very little recognition at the design stage about that end-of-life stage. So I think we need to be a lot smarter about designing to tackle that, whether that's by designing for formats that are reusable or refillable, like my coffee cup here this morning, or whether it's designing plastics so that they're much more compatible and safely compatible with the circular economy via recycling. And of course, the real starting point, if you think about this as a waste hierarchy, has to be about reduction. There are a whole heap of, I would say, plastic products that we probably didn't need in the first place. And given we've done such a poor job at designing for end of life, I think we can't afford the luxury of unnecessary items, because all of these bigger items, let's not forget, will be the microplastics and the nanoplastics of tomorrow. There is, of course, aspects of manufacture, particles that are manufactured to a small size and used in applications like cosmetics, for example, or paints, and that's another part that we need to address. But if you think about the total production of plastics, most of it is going via large items that are rapidly used, that then fragment in the environment into smaller pieces that will be the micro, nano of tomorrow.
So do you think governments will follow this principle that you're talking about, and why are they not following it yet?
Yeah, it's a good question. I mean, at the moment, we've got, I would say, what I call a once in a planet opportunity with the UN Plastic Pollution Treaty, that 180 or so nations have signed up to, and there's a real aspiration there, I think, to try to start using plastics more responsibly than we have done so far. So to me, this is the critical point in time where we've got that opportunity to do so. I think it isn't straightforward, and of course there'll be winners and losers in this. There are companies, individuals, whole nations, in fact, that have a bigger commercial stake in the plastic supply chain than others. And we need to try and manage this transition as fairly as possible. I think it's clear to everybody that there's a problem. I think the devil is in the detail of how do we solve that problem. There isn't a single answer to this. I mean, sometimes I hear people compare to success stories like ozone depletion, where we were talking about perhaps switching a propellant in aerosols as one aspect of it. That was complex enough, but here we're dealing with thousands of different permutations of plastics in a myriad of different products, thousands of different chemical permutations. Many of those chemicals that are used, they're put there with good reason: flame retardants, plasticizers, antimicrobials. But we need to find better ways of working. You know, one example I hear from some of the polymer chemists I work with is that we've got probably in excess of 20 different patents for the chemical formulation to make plastics bendable, to the plasticizers, to make them flexible and not brittle. And that might be fine at the design stage, but it creates a real headache at the end of life stage, because you've got all those different chemical ways of basically doing the same job, and they become inseparable in a recycling plant. And so we think we need to simplify greatly the number and diversity of different plastics and different plastic products, if we hope that the circular economy can really have a viable role. We've got to design for that circular economy. So I think there's a role here, in my mind, for all of us. A role for smart young scientists in terms of better design. There's a role for industry to finance those designs and to introduce more homogenized formats to simplify the range of plastic. There's a role of governments to enable that and to make sure that it's a level playing field for industry. And ultimately, there's a role for all of us in society to use plastics more responsibly, to use less of it, and to make sure that what we do use, we deal with it at end of life appropriately. And that's not to drop litter, it's not to contaminate the marine environment. And ideally, it's to make sure that we're buying products where it's necessary to have plastic. We're buying things that the waste can be dealt with locally. And that's easy for me to say in the UK. I have a highly sophisticated recycling truck visits my house every fortnight that is separated on the curbside into different components. But even there, with that level of sorting, we're struggling. And I say we're struggling, if you like, locally to recycle that material. Mainly, I would argue, in that case where we've got good collection separation, because of poor design. In other countries, the problem is there simply is no collection. So there's no one size fits all. We can't stop it entering the environment if it's not collected. So it's going to need answers right the way along the supply chain. It's designing less, it's designing smarter, it's using it more responsibly, and it's having systems in place to deal with that waste at the end of its life. And really, what I think we've got to do is join up the beginning and the end of life. So it isn't a straightforward problem, but in my view, it is a problem that we can fix. It isn't fundamentally. I mean, to put this in another way, many of the environmental challenges I've worked on as a marine biologist, the thing that's causing the harm to the environment is directly linked to something we as humans want. So if you think about taking fish from the oceans, of course we can try and do it sustainably. If I go fishing this morning, in the afternoon, there'll be that many less fish in the ocean than there were in the morning, because the thing we want is protein is directly linked to depletion. You could say the same for deep sea minerals. You could say the same for habitat loss. If I want to build a city on a coastline where there wasn't previously a city, or any kind of development, the thing we want is proportionately linked to the environmental loss or degradation. But with plastics, if you think about it, most of the uses, and here it depends on what we see as the harm. But if, as a marine biologist, and it isn't just about plastics in the ocean, of course, that's an example of where harm presents as a symptom of the problem. But virtually all of our uses of plastics could be achieved without the escape of plastics to the marine environment, with the exception of perhaps use in fisheries. I'm not for a minute pretending that that's the only problem associated with plastics. I see that the marine litter really is a symptom of a wider problem that I pointed to, the problem of a lack of appropriate design and disposal. But it isn't. The underlying point here is that our use of plastics doesn't need to be directly linked to harm to the environment. It's about using them more smartly, which absolutely includes using less of them. But it isn't necessarily about having to eliminate them from our lives. And that's where I guess I take exception with some of those that say we need a plastic-free aisle in the supermarket and we've got to stop using all plastic packaging, because actually I think we could see greater food wastage if we went for that approach. And so to me, it's about learning to use plastics more responsibly and to develop better models, better ways of doing that than perhaps the ones we initially developed back in the 1950s.
Well, I agree with you. It's not about just banning plastics and it's solved. Of course, that will not happen. We just need to learn how to use them better. So you just talked about how plastics are very different. They are a category that includes a lot of different chemicals and polymers. And so microplastics are also very different. And you have been involved to try to reach a consensual definition of microplastics and nanoplastics. And I think this is still something that is open in the field. And have you seen any progress in the past years? Or you'd like to comment on these difficulties in defining microplastics and nanoplastics and how it impacts the research that is being put out?
It's a really interesting question. And to me, it's almost a kind of circular question. So sometimes, I hear some of the science that's been done. I hear it criticized sometimes by policy and by industry that we're not using standard approaches, let's say, to monitor the environment, or we're not using standard approaches to detect microplastics or nanoplastics in laboratory settings. However, what I would say is that the science questions that have sat behind many of the studies that have been done so far have been different. You can't use the same approach to sample microplastics from snow near the top of Everest as you would use to sample mud from the deep sea or surface waters or beach sediment or a fish or a seabird. Each different question you're asking requires a slightly different approach. And that, I think, is absolutely fine in terms of the science of helping to understand the problem. The challenge, I think, comes more perhaps when we start to move from legislation into monitoring, where we want to know, well, what is it specifically that we need to legislate against, and then how do we monitor the effectiveness of change? So I think a key thing here is actually working out what is it we need the definition for. What's the purpose of the definition? I think that a definition from a policy sense may be slightly different to the way we might work experimentally, where sometimes what we're trying to do is to push the boundaries of the field. So to me, to some extent, it's slightly academic. I see micro and nanoplastics being part of a size spectrum that starts with plastic pieces in the environment, plastic litter, some of which is so large I can see it from satellites in space. And some of it is so small that it's below the level of detection for our best analytical. As a scientist interested in the effects of plastic in the environment, I'm interested in all of that. And of course, I want to know what name to put on it. But really, the thing of interest to me is the extent to which it might or might not be harmful based on its size, rather than what name you choose to give it, let's say. And I take the same argument when we get to the boundaries of the discussion as to whether a particular type of polymer is a plastic or not. We know, for example, that there are substantial quantities of tire particles entering the environment. Now, I consider those to be a microplastic particle. They certainly have high potential to be toxic. Some would argue that they might fall beyond the definition of plastic. So I think we can get tied up in knots here, and I think that there is a risk that the definitions, if we're not careful, might inadvertently create sort of almost loopholes for things that cause harm, but don't fall within a definition. So I think we need to be careful about thinking, what's the reason we want the definition? Why are we looking for that definition? And how do we then want to use it? And it's the same when you come to the monitoring. And I remember, being involved in discussions with G7 countries around harmonization of monitoring for microplastics. And the question I kept going back to was, what is it you want to monitor for? Why is it we want to monitor? And that's not that I'm saying we shouldn't monitor, but we need to understand why each government wants to monitor and what it's linked to, because it's really clear if you use a plankton net, let's say, of about 300 microns mesh size, particles smaller than that are likely to pass through the net. So you're never going to count them, right? So we need to make sure that we understand what it is we're trying to count and why. And to me, that's at the heart of this challenge around definitions. It's making sure we understand what we need the definition for, what we want it to achieve. Is it trying to achieve a better environmental status? Or is it about a definition so that if I'm doing an experiment in my lab and somebody else is doing one in another lab, we can use the same kinds of particles, the same size as the particle? Or is it a definition that actually relates more to the sampling gear? So I think to some extent we may be sort of struggling to look for this holy grail of a single definition of particles in the environment that's going to capture everything. And I think the most important thing is to think about what's the question we're trying to answer. Why do we need to define in each particular case? And I think it is critical that we have definitions, but I think there probably are operational definitions that are trying to fix a problem. It might be a slightly different operational discussion, a slightly different operational definition that we have from a policy point of view, as opposed to one that might be used in a laboratory experiment. But the key thing is to get those definitions written down. It's a little bit like terminology in a student essay. There's a whole range of terminology that can be interpreted differently by different people. And the thing I say to my students is, make clear in your essay what you mean by this particular term. So I kind of think we could beat ourselves up over this standardization and harmonization and where one particle stops being a microplastic when it becomes a nanoplastic. What we need to focus on is what is it that's causing harm and how do we reduce that?
Yeah, of course. And this is the same with the standardized methods, right? I think the only difficulty in this is to compare different studies made by different laboratories. And sometimes there is this trend to try to put it all in the same package, which is not necessarily true because they are different, right? If I'm testing a nanoplastic or a microplastic for toxicity, they will be different. And so maybe be more critical about the way we read the papers that are out there and not to try to compare things that are not comparable necessarily. But I see how this can be a problem, right? Because if we're trying to get something into law or to try to assess the toxicity, then it's very difficult to compare between different studies, or even, as you said, monitoring. It's difficult to compare if you're using a Mantotrol and another person is using the Nelson net. Maybe it will be a little bit difficult to compare between those two. So maybe just have a set, as you said, for legal purposes and monitoring related to governments. Maybe that we could have some standardized methods just to have this temporal data coming in over the years, so we can assess if we are doing if we are doing the right things, as you said before, right? If we are designing better, collecting better, and so on. So you have any opinion regarding the methods and all these problems regarding the way that we report the data? It's not only the methods, it's even the way we write the papers, what the sizes we use, the classes, the way we call the different forms of microplastics or shapes. Do you think we have some standardized reporting protocol for this?
I think it may be, the term I'd use is harmonized rather than standardized. But, you said a minute ago, it's difficult to compare studies because they might have used different methods. But the point I'm trying to make is that I don't see that as a criticism of the science. So all of those studies that you're saying we can't compare, they were not done with the purpose of a comparison between studies in mind. They were done to ask a particular scientific question. So we've looked at nanoparticles of particular sizes that we could manufacture in the lab, and we could incorporate a radio label. And we wanted to do that to look at uptake in a particular creature, and we picked size range that was of relevance to the model organism that we knew we could keep in the lab and study. If we'd chosen a different organism, we might have wanted to use different size particles. So that, I think the reason that many studies are not comparable, I don't think that should be seen as a flaw in those studies, because they were never designed to be comparable. I think where we need to bring in these comparable approaches is more when we shift from the exploratory science of defining the problem towards monitoring that problem. And I think, going back to where we started this discussion, it isn't yet clear which size of plastic, which type of plastic, which shape of microplastic is likely to present more or less harm in the environment. And I'm not even sure that we will ever get there, because I think that different shapes and sizes will present harm in different ways to different creatures. If we think about harm for a minute from plastics, I could think of a bottle on a beach. That might present economic harm, because if there's a lot of bottles, tourists might not like to visit that beach. Probably isn't all that biologically available, thinking of the plastic bottle in this case. So, it could have an economic impact. As it starts to fragment down into smaller pieces, it becomes less visible to the tourists on the beach, but it becomes more biologically available. So we might start to see harm to those organisms. As it breaks down even further, and maybe it gets into fish and shellfish on the beach, and perhaps that's detected and it becomes a news story, then suddenly it becomes economic harm again, because even if the fish are still safe to eat, people might not want to buy them. So, I've taken one bottle and I missed somewhere along the way. Let's imagine the cap has come off the bottle and the seabird has eaten it. That might be highly harmful to that seabird, because it might cause a blockage in ingestion. So it isn't the kind of material or range of products, I would say, here, where it's easily possible to adopt a kind of standard approach of this is an LC50 for all plastics, because the way even that one example of a plastic bottle might present harm is going to vary from its intact item as it breaks down. So I think we kind of need to take a more of a hazard-based approach, that plastics in the environment, whatever shape, size, or form, have the potential to cause harm, and we need to reduce them. And we need to think about how we tackle that. What are the solutions to reducing? And then maybe we can make monitoring to those solutions. Put that another way, in some countries I've seen things like, I'll go back to my example of the one plastic bottle on the beach there. In some countries they're adopting deposit return schemes, and there's pros and cons to whether that's the best answer, but there are certainly evidence that in places that have introduced a deposit to get them back, the numbers of bottles in the environment has decreased, let's say. But how do you monitor that? To me, the place to monitor it isn't the micro and nanoparticles that might at some time in the future come from that bottle. The thing you want to monitor is the number of new bottles. When I say new, what I mean is after the bottle return scheme came into place, the number of bottles that entered the environment after the scheme was adopted, as opposed to before. That's how you'll get to the efficacy of that particular approach and be able to quantify the reduction to the environment. So I think to some extent we need to change our monitoring strategies and couple them more to solutions. I think, while I think it's really important that we carry on counting litter on beaches and in the oceans, in the open environment, that's a long way from interventions. And so I think when we're talking about harmonization, I actually think we probably need to focus more on harmonized ways of looking at some of the interventions. And they might need to be quite specific types of monitoring. So what we're monitoring is a reduction in the rate of escape to the environment, or we're monitoring a reduction in production and consumption, or we're monitoring an increase in the extent of circularity of plastic. So there's a number of things we need to monitor that, to me, are a long way from a garbage patch in the middle of an ocean.
Yeah, of course. And so, in your opinion, there is already consensual scientific evidence that there is harm to the environment in one way or another. So, given the complexity of plastic pollution in our already stressed oceans, and the implementation of multi-target strategies is essential, what are your thoughts on existing plastic cleanup systems? And what is the best practice in terms of an effective approach to address this issue? Because sometimes these plastic cleanup systems either are not financially feasible in large scale to implement everywhere, and also they can have an impact on the ecosystems if they, for instance, trap animals or remove the nutrients from the environment. So what is your opinion? Where are we at this stage regarding these cleanup processes, and what do you think that could be done here?
Well, my opinion on this has been much the same for well over a decade, that at the moment, the rate of entry of plastics to the environment far exceeds any capacity for us to clean it up. You know, it's the analogy that I used more than a decade ago and has been widely used since is, if the bath is overflowing and the taps are turned on, do you start by mopping the bathroom floor or by turning off the taps? We've got to turn off that tap. And so another way I would put it, and sometimes people say, well, I'm against cleanup. I'm not against cleanup. I actually got interested in the whole question of plastic in the environment through participating in voluntary cleanup schemes. It's not that I'm against the idea of cleanup. My concern is that if we adopt cleanup as our center stage solution, then we're condemning our children and our children's children to carry on using the business models that we've got, polluting the environment, in the hope that they can pull it back out. We need more systemic answers to the problem. So, I sometimes say, well, let's imagine there's a really rich philanthropist, a donor in the audience listening to me giving a presentation, and they wanted some advice of how to spend their money. I would say at the moment, you need to invest 99% of it in turning off the tap. Maybe spend 1% on looking for smarter ways, technological ways to help with cleanup. But don't let's get things back to front. I mean, I kind of wish that all of the money that perhaps we've invested in technological cleanup had been invested in better ways to turn off the tap. I think we'd have seen if we'd achieved that, and we'd have turned the tap even a small amount closed, all of that rate of flow of plastics to the environment and potential increases in flow that have occurred over the last decade and might occur into the future would have been stopped. So the money would have been much more effectively spent than trying to take the plastic out. So at the minute, the priority has to be turning off the tap. I think in terms of cleanup, and we've been reviewing some of those practices with other scientists. I think that we're going to need to try to clean. It's not that I'm against cleanup. It's just where do we prioritize the spend? We should not and cannot see cleanup as a solution. It's a remedial kind of action. It's addressing the symptom rather than the problem. I would say that hand picking of litter, citizen science cleanups can be particularly valuable because they're low cost. If they're managed properly, they cause low environmental damage, and they can raise awareness of the problem. I would be cautious about investing in technological cleanups that might have the side effects that you've just spoken about. We tested one mechanical device here in Plymouth recently and published on it, and we showed that, it did catch very small quantities of plastic, but it also caught fish and other marine life, which by the time you came to enter the device were dead. And it captured quite a lot of seaweed that we really want to leave in the ocean. So the quantities of plastic were actually pretty trivial. But the quantities of marine life and seaweeds that trapped were more considerable. So it wasn't clear that the device was doing any good. But I can see that some of these devices are potentially attractive. If you own a marina or you run a local authority, you think we can buy a solution to the problem. And I don't think it's really that easy. And so I think there's also what the psychologists I work with call techno-optimism. That if we're not careful, some of these gadgets, if we don't think about them, if they're not properly tested, they might give people hope. That is a false hope, and so that's an additional worry for me that there might be a naive conception that we've solved the problem when actually really we haven't. And I saw exactly the same thing when we tested devices that were intended to intercept microfibers in washing machines. We tested a range of devices. There were only 2 of them that achieved a reduction in the rate of microfiber release into the wastewater from the washing machine. The others didn't really seem to do very much at all. And yet, they were being marketed as a solution. People were buying them because they wanted to believe that this was going to solve the problem. When really, actually, what we know already from some of the early science is that, there can be up to an 80% difference in the rate of release from garments according to the garment itself, to the design of that garment. And again, it puts I was going to say the burden of responsibility, and I mean that, but also the opportunity and the hope for change. It puts it clearly with the industry to design better products rather than continually relying on the consumer to deal with inadequacies of a lack of forethought, a lack of extended producer responsibility. we've got to take this from the design stage, rather than think about trying to fabricate smart cleanup answers. Let's stop it systemically. And just to go back to the fallacy of the washing machine filters, or the challenge there, we've also shown that half of all the emissions from garments come while you're wearing the garment, not while you're washing it. So anything you do in your washing machine is only ever, even if it was 100% effective on catching it from the wastewater, it's still only going to tackle half the problem. Whereas if we're smart about it and think about it from the design stage and design better textiles and fabrics in the first place, we could eliminate it irrespective of whether you're washing the garment, wearing the garment, and those solutions would apply even in countries where, the average member of the public isn't fortunate to have a washing machine or wastewater treatment plant. So we've got to think about systemic answers from the design stage, how to design out the problems rather than trying to fix it at the end of the pipe with some kind of technology. We've got to fix it with smarter technology at the start.
Yeah, of course. I think that is very insightful. And also, you've talked a lot about your experience because you've been working in this field for a very long time, and you're well regarded as a well recognized researcher. So another question we have here, because we have a lot of young researchers submitting to our journal, is if there were any particular challenges that you have faced during the years with your research experience, and how could you overcome these difficulties, especially not only about the microplastics, but about your career in general or being an academic? What challenges have you faced?
Well, I think there are always challenges, right? There are challenges for every creature on Earth. You think about, survival of young and losses to predation and all kinds of things. Everybody faces challenges, and I think we have to be resilient, and we have to find ways through those challenges. And sometimes I'd say it's a question of finding a way around the problem rather than trying to perhaps drive through it head on. There are always challenges. Sometimes it's financial challenges for doing the research. Sometimes it's competing things with my time. How to address all the things that I want to address with multiple things that I need to deliver, including, of course, teaching students, which I enjoy very much. Sometimes it's methodological constraints that we don't have the equipment or the equipment doesn't exist to undertake a particular thing. So then you're looking for ways around that, ways to solve the problem. And I'll say it now because there isn't a particular challenge immediately in front of me. I actually quite enjoy that part of the job because there is quite a satisfaction in finding your way and navigating around those challenges. Of course, when there's a fundamental problem immediately in front of you that's holding back the research, you don't necessarily see it so positive. But I think you've got to put a positive spin on it. You've got to expect that there will be those challenges. And I think it's, you can't just shrug your shoulders and give up. You're the only one really that can help to fix those. Sometimes I say to the students when they're, doing dissertation work with me, I say, yeah, you will encounter problems. I said, it's no good coming to me with problems. What I need you to come with is the problem and some possible solutions. What do you think we should do to solve the problem? And then we can talk very pragmatically. Well, what's the best shot out of those solutions? Which one do we think is going to be the most likely to succeed and still allow you to, if you like, answer the question that you set out to answer? So I think it's no good. There's no magic wand to problems. We just need to learn not to be too daunted by them and to look for ways to solve them, to either tackle them head on or to move around them in order to achieve the objectives. And we need to develop ways of looking at those alternatives to make sure that we don't get thrown off track, that we keep in mind. And I think, this is really easy to do if you're not careful, you need to keep in mind the original question. If it's a scientific question you set out to answer, the hypothesis you're trying to answer, a problem comes along, there is the potential that as you try to move around it, the steps that you take are no longer really answering the question you set out to answer. And there's two ways of solving that. Either you need to decide, well, actually, we're going to have to ask a slightly different question, so we can't answer this question. So we don't have the way, the means to do it. Or we need to think of another approach that will allow us to continue to address the question that we have in mind at the outset. So I think, you've got to be pragmatic about it. You've got to keep the question that you set out to answer in mind and be clear, is if I'm revising my approach, will I still be able to answer that question in a robust way or not? And it might be back to the drawing board.
Yeah, of course. But you've been very successful with these approaches, so I think it's very valuable for us to listen to your experience, to all these years of experience that have translated into such a great career. Actually, we'll also like to talk a little bit about your being a globally highly cited researcher. So your career is very successful. We're very happy to have you here. And following this question, we would like to have, do you have any suggestion beyond the ones you already said regarding reaching this stage in your career as a highly cited researcher? Do you think there is any insight on how to get there for new early researchers? And could you offer insights on writing papers, writing theses? Because this is a very difficult part for students generally, or for researchers getting into the field. All this seems very complicated, how to design the study, then write it, and then conduct the statistical analysis, and then go through the publishing process. So do you have any tips on that?
I mean, I think you've got to sort of follow your fortune and where there is a lot of luck in this. It was a chance question that came to me while I was working with volunteers cleaning beaches that I realized nobody was looking at small plastic. And so I asked some of my students to go and find the smallest bit of plastic on the beach. That's what started the work for me on microplastics. So, I saw an opportunity, but then I didn't give up on that opportunity. So it isn't just luck. This isn't like buying a lottery ticket, but at the same time, some will be luckier than others in the chance observations that they make. But they're turning those lucky opportunities into success is where the hard work and the tenacity come. I think that, the bit that I wish I knew better how to advise on, that I struggle with, is, working out what to turn down, what not to do, what things not to do, because my natural inclination is to say yes to participate in lots of things because I'm curious, and then I find I'm spread very thinly and I'm struggling sometimes. But at the same time, maybe it's been a good strategy because a lot of those things that whether it was a conference or workshop I participated in or a study with somebody that contacted me, it's very difficult, I think, at the beginning to anticipate which ones are going to yield some step change in our understanding and which ones aren't. I wish I had a magic formula to that, because if I did, I would have had more time, I don't know, to spend with my family, to spend with recreation. I wouldn't have been working late into the night, which I often do. I often still am. So I find it difficult knowing which things, if you like, which opportunities to take and which not to take. But excuse me, it's a strategy that's paid off for me, but it has been a lot of hard work. So I think there's luck, and I think there's hard work, and I wish I had some guidance on, how to decide what not to do. I remember emailing a colleague at another lab probably 15 years ago. I think we wanted to do modeling work about, and I'm not a mathematical model, but modeling work about plastics distribution in the oceans, and I wanted some help. And I got an answer back later that afternoon to say, and he was somebody that had the expertise, and he said, no, I'm not interested because it doesn't, it's not the core part of my research. And I really respected that. And I thought, I wonder how you reached that decision, because I think I might have struggled to reach the same decision. He definitely had the skills to answer the problem, and it's no criticism of him that he decided he didn't want to. I mean, other great modelers have gone on and done that work, and there've been key papers in Science and Nature. But his decision at the time was no, it wasn't part of his key research, and you got to be able to say no. And I heard somebody the other day say, when I mean, you said, well, when I do say no to something, I make a note of it. So later on, I can reflect back and think, was that a good decision or a bad decision to say no to that particular thing? So the saying no is sometimes the hard thing. I think you need to reflect on it, but you're not going to achieve the success if you don't say yes to things and you don't seize the opportunities. So to me, the saying yes part's been more important than the saying no. I just wish I knew better how to say no sometimes to collaborative opportunities, let's say. So what else did you say? You talked about writing and difficulties. And, I mean, of course, science is challenging, right? And that's why we spend years of study as training to become a scientist, to practice, going through a degree, perhaps a master's, a PhD, then probably a postdoc, before you're even eligible, perhaps in some countries, to win the resource to conduct independent studies and to lead studies. You're looking at probably a decade or more of kind of mentoring and training, before you're in a lucky position maybe to win a big grant. Of course, some are lucky earlier, but, it can be something like a decade. So that's a lot of training. There's no way I can hand that over in a book. It's the experience that you gave. You talked about writing. I think that one thing that I found that worked for me, but possibly doesn't work for others. When I first started, I'm thinking back to my PhD time and some of the first papers, I always tended to write the abstract last because I just saw it as a summary of the paper. And kind of is, but there's always this temptation to want to write down everything you've done. Scientific paper isn't necessarily, it's not a chronological story of everything you've done. It's not an account that needs necessarily to spend an equal number of words sort of in proportion to the time you put into something. One experiment you did that might contribute to a paper might have taken you weeks and weeks or months and months. And another experiment might have happened really quite quickly. But it could be that the quick thing that didn't take much time is actually at the heart of the paper. The thing that took a long time was fundamental in getting you there. But then when you come to write the story, probably that the heart, the backbone of that story is actually is the quicker part in that instance rather than the slower part. So I think you need to separate out the written account as a published paper of what is the advancement from the chronological process and the time steps you put into doing it. So in my view, what I do now is, of course, I need to get to the state where I've worked up the results and things enough that I feel I've got good understanding of what the paper is going to be about. I then try and sit myself in a room without computers or phones or anything else, and I pick up a pen and I try and write an abstract. And it might be a slightly longer abstract, but I try to write sentences about why I needed to do the work, what it was we did, what we found out, and why it matters. And then if I've got that and I think I'm happy with it, and it's almost like, it's almost like a summary if you imagine it was a conversation with a friend that wasn't a scientist. How would you explain what it is that you're doing? Something like that. When I've got that, I kind of see that then as almost like a recipe for the paper itself. But if I'm saying this is why I'm did the work, that's why it matters. Well, that's got to be a key part of my introduction. If I've said how I went about it, then those are the bits I need to unpack in the methods. What are the 2 to 3 sentences I put in my, dummy abstract about the results? Well, those are things that must have a graph about. And if I've got a graph in there that didn't feature in my summary sentence, got to ask the question, well, what is simply because I drew that graph 3 months ago because it seemed important at the time? Maybe it doesn't need to be there because those graphics, those illustrations will be one of the things the reader will look at and potentially can throw them off the track. And then, what are the take-home messages? But then the key thing I'd say about this approach is I would use it in an iterative way. So I've now written my, short draft abstract, try and unpack that into the paper. And as I go through it, I realize I'm actually having to write something in the results section that somehow differs from my draft abstract. I've got to question then which bit's wrong. Is it actually that I need to change the draft abstract, or is it that I'm putting the wrong bits in the results section? And I keep getting them to agree with each other. The science that I've discovered isn't changing as I do that. What's changing is what's the bit that I need to tell the reader about and how do I best go about doing it. So I've found that really helpful, getting to the stage where I can write, because I can never conceptualize the whole paper in my head. as though I could dictate it to a dictaphone. I've seen some scientists that they can hold the whole thing and they can almost start talking. I can't do that. So I start by trying to get to the stage where I can write the abstract and then I unpack it into the paper.
So I think that is the difficult. Sorry.
I keep checking back. Is it right? Are the two things in agreement? That's the key bit.
Yeah, I agree with you. I think that is the difficult part. At least I see it with my students, that what is the story? They cannot identify the story, and then they weight the results all the same, but they are not fundamental to the story. Some are side stories or backstories of the characters, and we need to be able to first identify the backstory, which is the backbone of the paper, as you said, and then that helps you structure, because basically it's a narrative, right? We're communicating with the reader, and it has to have some flow, some interest throughout it to reach a good story that people want to read. Because I don't know what is your opinion, but in my opinion, the way you communicate, you can have a very good result and maybe be the next Nobel Prize, but if you do not communicate it well, you will never reach that stage. So this is a very important part, right? To write it, to find the story, to improve your writing, really your writing skills. And do you have any tips on how to develop that? Do you recommend reading literature, or just literature? I'm saying not necessarily only scientific papers, but also books. Not books on writing or scientific books necessarily, but just improving your writing skills and reading skills.
Of course. I mean, anything you can do to improve your writing and reading skills. And it's not something that comes naturally to me. It's something I have to work hard at. I see others that, it comes really naturally. And I remember, I can remember really vividly, I think the first chapter or piece of work I handed in to one of my supervisors during my PhD. And it was probably 20 or 30 pages. It was a reasonably long piece of work. Anyway, he handed it back to me and he said, "Richard, it feels as though you've thrown the words in the air and they have landed on the paper completely at random." And I was pretty horrified by this, because I thought I'd put an awful lot of work into it. And he was finding it impenetrable to read. And I think, so the strategy is, it's kind of what I've just described. It's making sure you're really clear about what's the message that I want to communicate. It isn't, and I think if I remember back, that was part of the literature review of my thesis. So I'd read lots of literature and I was trying to summarize it, but I didn't really have a clear structure. And so that was why it felt to him like the words had fallen at random. And I think you need to think, you need to be clear, what's the structure? What are the key ingredients, whether it's a paper, a literature review, whatever. And then so I try to come up with a kind of a menu of subheadings, and then I try to fill them out. And sometimes, think of my other supervisor during my PhD. He'd say his approach was that he'd set himself a mini exam question. So if we'd got some subheadings written out, he'd try and go away and work on writing that one section rather than trying to think about the thing in its entirety. You set yourself mini exam questions to try and answer the subheading. But you've got to come up with a clear structure, a kind of recipe for what needs to be in the piece of science you're trying to communicate. Otherwise, I think it'll take you a long time to kind of get there by the words falling on the page at random, if you like. Of course, that was an exaggeration, and he was trying to shock me into doing the right thing. But I mean, it's worked, because all these years later, I still remember him saying that.
Yeah, and as I think another problem that you just described with the words falling randomly in the page is that the first draft that you write will never be finalized. You need to edit it. And I think sometimes students think that they will write something, there will be small corrections, and it will be done. It's not like that, right? It's not just for me that I need to edit several times until I reach a final stage of the manuscript. And do you have any tips on how to edit and to expect that you will need to rewrite the things a lot of times until you reach a final stage where the story is well written and consistent between the different sections?
I mean, yeah, this isn't a criticism. You use the word students, and I kind of think we're all we're all. I don't necessarily. I've learned ways,
Yeah.
but it's not like I suddenly went through a transition when I stopped being a student. And I think that and I wouldn't want to lead a student listening to this into thinking that they're going to suddenly pass this threshold where they're no longer a student.
Yeah.
I'm always a student, right? And I'm learning for better ways to do it. But one thing, because I think my inclination is to be a little bit last minute sometimes in things that I'm putting things off and thinking I've got time and I'm trying to do it then in a hurry, and that doesn't work well. I think in terms of writing, I think I didn't. It wasn't something that came to me naturally, so I would tend to postpone it. And I think I actually find it a lot easier if I've got the time to consider it, and so things that I didn't expect would happen that do. So even I suppose when I'm starting to engage with a particular topic, if I can do some preliminary work on it, maybe trying to come up with that draft table of contents or whatever it might be. Let's imagine it was before the Christmas break or something like that. If I could get that far, even though if I'm going to take a break or go on holiday for 2 weeks, if I could do that one task of coming up with that possible list, it does something in my head. Well, I'm, and the same with writing that draft abstract that I spoke about. Even if I just wrote that before I went on a holiday, if I come back and then try to turn those notes into something, it's already better text. And I don't quite know how that's happened. It's like, somewhere in my head, it's whirring away a little bit. So I think starting early with something that's fairly straightforward. I talked about that, writing that abstract. Even, by the time I've handwritten it somewhere in a quiet space, even by the time I come to maybe type to word process it, I feel like my brain has processed it a bit and it's already a better draft. I'm not necessarily having to read it word by word and write sentences that I've scribbled down. It's already started to organize itself. So I think leaving yourself time between different drafts really helps. And I think, and I noticed it myself with, I'm working on a grant application at the minute, and I thought we'd got it nearly there before Christmas. It's just been the Christmas holiday now, and I came back and looked at it, and immediately in the first sentence, I can see, the wrong spelling of 2 words, or something in completely the wrong order, or a keyword missing, because you get blind to it, because you think you know what you're trying to say, and you're imagining that it's there, and actually you read the sentence again, and you think, well, it makes no sense because the keyword is actually missing. So I think trying to plan so you've got time for your brain to process things, and also for you to look at what you've written like a fresh pair of eyes. If you're short on that time, then it can definitely help. I mean, it can always help with giving it somebody else to read, to look at, a second pair of eyes to see which bits didn't you understand very clearly. But I think, to me, that part excuse me, probably comes a little bit later on, because otherwise your friend or your colleague is almost trying to restructure it the way that they would write it. And so you've got to get it really quite close, I think, before that second pair of eyes can really help you, because there's no if you picture any of the papers I've written, I'd say there's no single right way of writing them that's going to get it published. You could have written it in a different way and it would have been a publishable paper. The point is, it needs to be of that standard. It needs to be appropriately written and clear, rather than in this other category that's inappropriate. But there's a number of ways that could get you to, in terms of the way you structure it and write it and organize it in that central thread. Not that there's one magic answer. So I do like to use colleagues to help me, but I think I've got to have it quite a near stage, if you like, where they're really helping me polish it. Unless it's something more fundamental, where I'm actually saying, I need to think how to structure it. And then I might go and have a coffee with them and say, this is the story I'm trying to tell, and just talk it over and see if it clarifies a bit. But if the writing is a complete jumble, it maybe doesn't help to give it to somebody else, because they're just going to come back and say, it feels like the words have fallen at random on the page. So it's when and where to use that extra help as well.
Yeah, of course, because it's very important to put yourself in the position of a reader, right?
Yes.
Or have someone else do that, because you see what is clear or not for us that are inside the job, the work, we can easily see in our minds the missing words and maybe the missing sentence describing the methods or something like that, because for us it's obvious, but for the reader it is not. So it's good to have these two stages.
It's a really, I mean, yeah, it's a powerful phrase you use. And now I go back to the same PhD supervisor, and in an acknowledgement in the front of my thesis, I thank him for introducing me to a character that he used to call the poor reader. And he'd say, you know, Richard, think of the poor reader. How are they going to understand this, right? And yeah, it's really true. You've got to put yourself in the shoes of the reader.
Yeah, I think this is the very important. I think we've touched all the really important parts of writing, and of course, do not have high expectations that the first thing you'll write will be perfect, and so just keep going at it, and you will improve through the years. But I think the most part is just managing your expectations of not reaching immediately a final version. Then we'll go back a little bit now to your career to finish. And we know that you work a lot with the marine ecosystem, and so we would like to address blue economy because this is also related with plastics. Maybe there are some opportunities here to handle the ocean plastics, and we know this is not the priority. The priority is to better design, improve the waste management, and all that. But considering ocean plastics that are already there and are having an impact. Is there any opportunity through the blue economy approach to get some valuable goods out of these plastics, and maybe any insights on how to improve this and how to communicate with policymakers and researchers about the microplastics and the plastics problem in the oceans?
Yeah, it's quite a complex question. I think the answer is not straightforward. I think understanding the way that plastics affects the economy is really important for industry and policymakers in terms of justifying actions and interventions. And it's really clear that plastics have a negative effect on the economy. You could think of tourism or damage to fisheries or a whole range of other things. And that economy that's damaged by plastics, because of course plastics is in itself an economy, but our current use of plastics, one of the ways it presents harm is that it damages other types of economies. It has externalities to the way we use plastics. Plastics are seen as inexpensive, but actually they're not inexpensive when you consider all of the harms that are external to the producer and consumer. And some of those harms are economic. And so you could have a use of plastics that was affecting something that was effectively a more blue economy measure. So in essence, plastics can challenge some can cause economic harm, and that could be harm to something that's blue economic, if you like, or green economic, or harm to something that's economic that is actually also environmentally damaging. So they cause economic harm, I think is the first point I want to make. I'm not sure that I really see I mean, you talked about removing plastics. I don't see removing plastics as being part of a blue economy. I mean, I think I'd be really cautious about that. It feels like it goes back to the sort of techno-optimism we were talking about. Not against the idea of removing plastics from the ocean, but if you're talking about turning that plastic into something, the potential for plastics to become a new product, if you like, by recycling or reuse, are orders of magnitude greater if we capture that plastic before it enters the environment, rather than when it comes back onto the beach as a flip flop or whatever it might be. And I've got art pieces at home that are made out of plastic from beaches and plastics from the environment, and I'm curious to buy them, but I don't really see it. It's not part of the answer, if you see what I mean. I think, and there I have it intrigues me because I've worked a lot with artists, different forms, really, from dance to photography to sculpture, that have used plastic debris as a part of the context of their work, and I find that really fascinating. It goes back to your communication point. Can some of those artistic representations help to convey a story that I could never do via a scientific paper or some poster? So one of the things we tried to do working with the psychologists was to see if we could evaluate the public's perception of the problem as they went to look at some of these exhibits. And actually, we found it really quite challenging to be able to do that, because people will find them fascinating and sometimes beautiful. But then I'm asking the question, well, has that actually helped us address the problem? So I'm not quite sure exactly what you're driving at with the blue economy, but I think I would be cautious about thinking of plastics in the environment as being part of the blue economy.
Oh, of course. And do you think, you just talked about the economic impacts of plastics in the oceans or in the environment? Do you think, and before we talked about we need to monitor if the plastics are having an impact and how the measures that we are taking are translating into lower amount of plastics in the environment. Do you think that maybe quantifying these economic impacts could bring light to the problem of the plastics and maybe be even an indicator of the successful measures that we are taking?
Yes, absolutely. I mean, when I came into this problem as a marine biologist, and so when my initial work was on quantifying the distribution, right? And then people asked me, well, is the microplastic harmful? And so, of course, I started to use biological models to look at that, because that was my background. But when I came to talk with wider audiences, particularly policy, I realized that people saw harm in different ways, and it's a phrase that kind of come back to in my mind, because when I was involved in helping to draft some of the text for the EU Marine Strategy Framework Directive, and it says that the quantities of plastic and microplastics shouldn't cause harm. And when we got that text, I was really excited that we got this was a real positive step. And then we sat down with policymakers from different member states, and I realized that all of them saw harm in a very different way. And the term harm was quite subjective. It wasn't really a scientific term. For one scientist, they said, well, to me, if there's any marine animal that it suffers as a consequence of plastic, that's clearly harm. But for one policymaker, they said, well, until you scientists basically get out there and show me that this stuff's harmful to a human, I'm not going to do anything about it in my particular country. So the bar for harm was really very different for her. So in answer to your question, my response to this has been to try to assess harm in different ways, using different currencies. So I tend to talk about the harm to wildlife, the numbers of different species, the ways that it has that harm in the environment. I also talk about the harm to human health and well-being, whether that's loss of life from vessels that have sunk at sea because of entanglement in nets, or whether it's the psychological damage that we've shown that maybe damage is a bit too great, but we showed with a perception study that even small quantities of litter in the natural environment reduce that feel-good factor of going to the natural environment. We normally go to the sea. The marine environment makes you feel good, doesn't take much litter to significantly address that. And of course, there's other human health aspects that we're delving into. And then, of course, there's the economic part. You can put the currency on it, the cost we spend in cleanup, in removal technology, whatever it might be. There are ways you can put a dollar sign on it. The environmental, the cost to the environment and the habitats that are damaged. So a whole range of ways you can look at it. And some see it in that sense. So I think we need to be prepared to talk about harm in a range of different currencies, because those currencies have relevance to people differently, and they help you see then a way to prioritizing solutions slightly differently. So I think you've got to be prepared to use different ways of expressing harm, because there isn't a single harm out there. There are many different types of harm, and people see it different. But understanding it, trying to quantify it, absolutely helps to put pressure to move towards solutions. Yeah.
So you think, is there any indicator or measure that is better suited for having governmental impact? Because we know that different people have different moral values, or they measure different things. They weight in importance different things. Maybe for me, the environmental impact is very important, but maybe for an industry, the importance is not that, is their image, if they can sell the product. And maybe for a government, this kind of economic impacts have a greater concern for them, because they are losing money either because they do not get the tourists here, or because they are spending it cleaning up all the waste so that people can come and enjoy the beach. So do you think that we have to set these different indicators, and what indicators would you suggest?
Well, I think I go back to what I just said, but I'll shorten it a bit. For me, I think the best thing to do is to present the evidence of harm from a range of different perspectives. And I think it would be one-sided if I just presented economic harm, or I just presented harm to human health. I tried to present the whole picture, and I think that different people will always take away from that different things and different priorities. Of course, if I get a policymaker come to me and say, I want to know about the economic harm specifically, then that's what I'll try to give them. But I think if I'm articulating harm about the issue of plastics in the environment, I will try to talk about it from a range of perspectives, because I know that my audience will take away different things from that.
Yeah, and I think that is a very good point, and also connects with the stories and how to communicate science. I think that summarizes it all. So we are at the end of our meeting here today. We are very grateful to have you here and share all this experience and your opinions on these topics. I think it was very interesting. I learned a lot, and I think our viewers will also enjoy it and get a lot of information from your talk.